Okay. This is exactly the presentation I gave at TTSO. I didn't make any modifications at all. But called Venus Ashen Light Lunar Occultation. How dark is the dark side of Venus? That is. Uh, so. Um, so I just added here. It was on the 27th of March at the TTSO, and also now at IOTA here. So it's observation of the reappearance of Venus from the moon. It was October 9th, local time, October 8th, UT, north of Alice Springs. Next slide. The one thing I'm disappointed about that event is, we had the one recording with a 10-inch suitcase telescope, and I made a visual observation with an 8-inch celestron that we had to see if I could see it visually like other people had tried, and I didn't see anything visually. Didn't notice Venus until the bright parts started to reappear. But I wish we had a mighty mini out just getting the whole moon and Venus reappearing. It was such a beautiful sight, and looking afterwards, and I said, oh, darn, man, we should get a picture of that. It's so pretty. Um, but anyway, historically, the Ashen Light was first reported back by Riccoli in 9 January 1653, and he called it the Ashen Light. Subsequent claims have been made of seeing it by many very famous observers: Sir William Herschel, Patrick Moore, Dale Cruikshank, and William Hartmann in more modern times. Monte Carlo simulation indicates that lightning hypothesis is the cause of the glow. Can't explain it. There's just not enough light would be transmitted through the atmosphere to be seen from Earth. Observers suspected it may be illusory, just resulting from the physiological effect of observing a bright crescent-shaped object, -4, -5 magnitude almost, and trying to see something on the dark side of that. Some spacecraft looking for it have not been able to spot it, leading some astronomers to believe it's just a myth. We know there is a glow in the infrared from just thermal emission from the planet and the cooling in the night time, um, but it's pretty faint, and that I believe has been detected from spacecraft. But these are pictures that were made in 1958-59 by some observers, just showing what they thought they saw. I mean, of course, everyone knows about the Earthshine and the moon that we see all the time, and people say, well, there should be the same thing on Venus, but there's no Earth to shine on the dark side of Venus, so at least it's pretty feeble. Next slide. This just gives a recap. In the mid-20th century, some observers realized that the Venus Ashen Light, if it exists, could be observed for many seconds without interference from the glare of the planet during an occultation. So visual, someone actually tried to do that in the United Kingdom in the I think 1930s. Sometimes I don't know where. There's an article in the Journal of the British Astronomical Association that we should try to find to just mention that. And they got an inconclusive or negative result, though. They didn't say, no, yeah, you could see the Ashen Light. No, they didn't say that. But since then, there hasn't been much done on it. I mean, there were some observations in the 50s, there's things. But as far as an occultation goes, though, there wasn't anything done until the 17th of July 2001, when there was a good occultation that occurred over Kwajalein Island in the Marshall Islands, and there's a lot of tracking stations there for our Western Test Range, where they tested the ICBMs in the early days to see how accurately they could hit different parts of Kwajalein. So anyway, there's a thing called the Kwajalein Hourglass, a local publication, and there's an article on that on page 8 of the July 24th issue of that, so just a week after that. They made the statement, though, there that said that science may have to wait for another time before the mystery of the Ashen Light of Venus is solved. When 67% sunlit Venus reappeared from behind the 13% waning moon. So they still had 20 seconds or so of time when the dark side was visible. As it said, they said none of the observers of this 2001 occurrence, including some using a 61 centimeter super ray dots telescope, reported seeing the ashen light. Video from the event was captured, but the camera was so insensitive that they weren't even able to detect lunar earthshine. So they tried to do a video, but they just didn't have they didn't even have the PC 164C cameras that we have now. Those are just coming online at that time. They might have had something like the PC 23C or something. If they'd used that, they might have done better, but I don't know. But anyway, there's one picture that this one fellow caught of the occultation after it reappeared, just you know, using an afocal thing through a 6-inch reflector. So, um, so the event we observed the dark. This is a series of slides then that Bill Hanna put together at TTS09. He showed these to try to encourage interest in this event. The just mentioned about if there is anything, it should be unambiguous because it would be visible for over 30 seconds. Um, and and he said to encourage that the spectral response matches visual observer, you should have some sort of blocking filter or something. We didn't do any of that. We just just went all out to see what we could do. And anyway, go to the next slide. And you have this nice table showing the predictions for all these places along the Stewart Highway, going north and south from Alice Springs. Here's the prediction for Alice Springs, but we were prepared to travel wherever we needed to for this event. Next slide. I mean, you couldn't see it on the east coast of Australia. It was only in the central part of the country that it was visible. Because on the East Coast the reappearance occurred in morning, in too bright morning twilight. So there was only one other observation that was even attempted that I know of, and that was by Richard Williamson, who was from Alice Springs, but he was visiting relatives in Wool Bay in South Australia near Adelaide, and he set up with a 70 millimeter refractor, I think it was, or telephoto, no, 700 millimeter telephoto lens. And he did get a nice recording before the occultation, or after the occultation of the, sorry, but right during the event he had a grays cloud come over and wiped him out just at the critical time. So he was talking about distribution, try to set up number to improve the odds of having good weather and so forth. And it was kind of low elevation. It was 13 or 15 degrees high, so it was. And so he talked about different things for the cameras. So you can mention more if you want. But I think next slide.
I clearly wasn't persuasive enough.
Right.
It was only you.
Right. So this was the weather forecast. The Skippy Sky forecasts were quite favorable for Central Australia. You can see the usual cloudiness around the edges, though. As the night approached, we did have some scattered clouds during the day that weren't strongly predicted, or even. Before, there was a patch of clouds northwest of Alice Springs that we watched on the IR satellite images. There's much better. While we were there, this Japanese weather satellite came online, and they have much higher resolution images than we have had before available now. So it's really remarkable that the detail. But anyway, 3 hours before the event, it was obvious the weather was going to be fine around Alice Springs, so there was no point in running 50 or 100 miles north or south or anything. So we just selected a convenient location in the desert a few kilometers north of town where we could get out of the light pollution of the town. Next slide. This just shows our observing spot. They actually name it Urukmi. But it's really just, there's no houses or anything there. I don't know how it got that name. But Alice Springs itself is, the different suburbs are named, and we lived in the Breitling, the northernmost suburb of Alice Springs, in the apartment we stayed at there. And this is a zoomed-in view of this place. There was a big flat dirt parking area east of the highway where some trucks could pull off if they wanted to. Pretty close. It was just a few hundred meters north of the Alice Springs sign, but it had just a completely open view to the east. It was just a gorgeous sight. Next slide. This shows the 10-inch suitcase telescope. This was set up for another thing, but that's the scope we used. John Broughton's design. The camera is at prime focus, so the images are reversed, so because there's only one reflection. So not like a Newtonian where you have two reflections and you get a right side image then. But we usually normally use it for pre-pointing for occultations of faint stars by asteroids, but this is the biggest aperture we had to do this event. So we decided to use it. Next slide. This just shows the prediction, and there was this other star. Um, there was Venus's 32nd arc disk, 40% sunlit disk would occur at a cusp angle of 78 degrees north with a 15% sunlit moon, the moon being 13 degrees above the eastern horizon, and the predicted contacts are shown there. And orientation, as Joan's video recorded it with a 10-inch suitcase. She was running that while I was observing visually. And we used a Waytech 120N camera with two-frame integration while I observe. And I say show the video. We won't do that. I think we showed it at the last meeting, and it's available online. Anyone can look at it whenever they want. But anyway, some analysis of this has been done. A lot of work by Scotty Dagenhart and Tony George, and you did a lot of work too on it at the time, Roger. And there have been some important critiques by the different work by Dave Harold. He was sort of devil's advocate and trying to get people to do it right. Anyway, this is the YouTube link for it, and the analysis actually was Richard Wild's sort of browbeat Scotty, who's been sort of out of IOTA activities for a while, but he browbeated Scotty and got him interested enough to do a lot of work on it. So next slide. So anyway, there were then reports by the three different analyses. And Scotty sort of put together the best sort of presentation for him, so I show a few of his slides. Anyway, he shows relative intensity measurements show the unlit disk of Venus to be fainter than the Earth-lit moon and a 9.6 magnitude field star, but brighter than the 11.4 magnitude field star that whose reappearance we recorded also. Next slide. This just shows Scotty's interpretation photo. This is the photometric curve that he got of Venus. This shows before the occultation, and this shows when the sunlit part started to appear. Of course, it shot up, but he claims there's a period in between where there was definitely a slope going up, indicating that the Earthshine was detected in our video. But it's very faint.
Individual frames that he took out of the video. He didn't use live movie. He actually took the image in individual frames into his analysis program.
Okay.
To measure the brightness.
Okay. Yeah. He. So you probably can give the presentation better than me, because we just made the observations and we let the experts.
We looked at it, there's no way anybody could see this visually.
Yeah, right.
That's all we were trying to do.
Yeah. I mean, that was the goal, and I think we've proven that if there may be some ashen light there, but it's so faint that there's no way that a visual observer could see it with the sunlit part of Venus in the same field of view. Even blocking with a bar or something, different things that you can
Not
do.
visually, but
Yeah.
according to this,
Mhm.
detectable with instrumentation.
Yeah. I mean, and this is the only time. This is the first time we've gotten a sensitive video recording, before.
Indicates something there.
Yeah. Don?
There is.
Yeah.
Yeah. Well, I mean,
Mhm. The dark side, yeah.
lit side, yeah. Was it back in the 80s or so, y'all went to Africa? Was it for the same?
Oh, no, yeah, in 1981, I think it was, we went to Somalia to observe an occultation of Nunki by Venus. So that was different, so, right, right. It wasn't Venus, the moon called him Venus. Um, but, um, but anyway, I'll show at the end of the talk, I'll show the future possibilities, and it's not common that you can get a good geometry doing this in an area that you can easily get to. So, I mean, it's about as rare as a total eclipse of the sun. Rarer actually, yeah. Yeah.
Telescope you were using?
Yeah, there was that 10-inch scope that I showed, the suitcase scope. John Broughton contraption. And this shows, what Scotty showed. He shows that says this is, you can see a little slight bump there. And Dave Harold said, no, that's a lunar mountain. And so he said, Dave Harold stressed you had to do the analysis for points at other parts of the limb and show that there was no, slope versus the one in the middle which did show a slope. If you had if you can show that, do the same analysis for other points along the limb of the moon, then Dave said, yeah, that's the way to show it. So Dave Harold said, oh, this is interesting, but he said, I won't get into the arguments of one way or the other. Don?
Okay, what you're saying is the moon and Earth shine, but
Yes.
where is Venus emerging?
Right at the arrow, right at the end of the arrow there. Yeah, you can hardly see it, but it looks, if you get up close, you can see what may be a little bit of a hump there. And you'll see in other slides, Scotty does some additions and different things to bring it out more. So next slide. So this just shows a zoomed and contrast enhancement of it. So next slide. And this just shows pixels at different times and things, showing different frames, and so he's trying to quantify that reappearance. And so, I mean, he claims he's convinced that there is really something there, but it's at this faint level. It's brighter than 11th magnitude in terms of surface area, but fainter than a 9.6, fainter than a 10th magnitude star. So next slide. And this just shows the geometry. Next slide. And intensity gradient shows, this is what he shows, this kind of a predicted intensity gradient, and an estimate of 8 pixels matching something, the radius of Venus. Intensity of Earth-lit moon and 2 field stars. He shows the differences. So this is the unlit Venus disk down here, and these are the field stars, the 2 stars, and then this is the Earthshine here. So you can see it's quite a bit down. It's a third or less of the brightness of the Earthshine. Next slide. And this shows the bright side just starting to reappear, and this is, he's added, co-added several frames to show that, and he claims you can see the dark side just barely, with a little bit of showing it's in the right place for this to happen. It's just a peak of the cusp. Next, Tony George did an analysis, and this is what he found. Found flat right up until the sunlit part of Venus started to reappear. So he got kind of an opposite result. It shows his lie movie analysis. And he did it for 3 different apertures, showing.
It really was done very differently.
Mm-hmm.
Tony used an aperture that included, this aperture was greater than the diameter of Venus, of the whole planet.
Right, okay.
And Scotty extracted from that aperture a small aperture in its center,
Mm-hmm.
and got the light from that. So the point is, Tony insisted that it had to be evident in a larger aperture.
Uh-huh.
Somehow it didn't count.
Uh-huh.
I don't understand that philosophy, but
Right.
but Tony was measuring something different.
Okay, yeah, yeah, he would, is bound to include a little bit of, right. Yeah, I
It
see.
makes it less sensitive. I mean, if you have
Right.
a larger aperture for a small point of light, then you're less sensitive to changes in that point of light.
Yeah, yeah, that was, I don't know if everyone heard that, but Roger was saying that the sensitivity that Tony George is getting is different from what Scotty did, because Tony George used a larger aperture, larger than the planet, whereas Scotty's was smaller. Tony George said if you can't see it in the larger aperture, which you're sure will get the planet, if you don't see it there, then it's not real. But but it's less sensitive what he did. So that's probably maybe the explanation. Next slide. So Tony's conclusions. Of course, everyone complained about the motion and everything else because the telescope was not guided or anything except by Joan turning a crank to keep the elevation up right every once in a while, and um, and there was a bit of a focusing problem. One side was out of focus, but the field of the part where Venus was fairly good focus. It wasn't perfect. It's hard to focus that telescope. I've learned better how to do it since using it more, but we had what we had at the time and used it the way we knew it. so um, so certainly you can do a lot better with better equipment and everything, but you have to take it to where the opportunities are, and how valuable it is. I think we've proven the main thing we wanted to do, that maybe there's something there, but it just seems too faint to be something that the visual observers in the 19th century or 18th century could have seen. Um, so anyway, these are. He says, unfortunately, this work does not corroborate to Scotty's findings. It was also discouraging to hear from Scotty that the program and processing he used is too complicated to be reviewed or reproduced by someone else. And for now, he thinks we're left with a conundrum. And he does agree, Scotty, that we've learned a lot from this exercise and how future observations may be improved. So yeah, it'd be nice to have a tracking telescope and so forth to get better photometry. It's one thing, people who do exoplanet work, they go to huge amounts of effort to get really good tracking for their equipment. So they always stay within a pixel or two of the star during hours of tracking. And that can be done, but you have to be very careful, have really a good mount and everything. And we just don't do that for occultations because we don't need it. Very right.
Tony also, a substantial amount of movement present in the registered images.
Uh-huh.
I took great pains to divide the video into sections and register each section independently of the others, and then register them all.
Uh-huh.
And the point is, I want to say that I succeeded in eliminating movement in the registered images, and it was all within 1 pixel. There was no movement greater than 1 pixel in the way I registered the images.
Great, yeah.
And he says there's a lot of movement, and I said, well, that may be part of the reason he didn't detect what
Right, right. He just used a bigger aperture to try to take care of that effect. Yeah, yeah, yeah. Yeah, we're trying to write up a paper about this, and Joan is, offered to do it. So we're getting good information here. Right. Yeah.
And other things, like both air conditioning units in our house.
Okay. We can go to the next one. So next we have Roger Venable's analysis, and he just mentioned how he was able to remove the movement and register things properly, so you were all within the same pixels area and everything. After stacking the video to eliminate the effects of that no small task, he used the measurement frame shown to the left, my movie, and the Venus dark side reappearance is shown below, and he gets a non-zero slope. so that's so next slide. So this shows the light curve, and you can see that here's before the occultation, and you can see it slightly going up here, and then zoom the big the star starts reappearing. So so the light detected from Venus brightens rapidly even in saturating pixels before the actual cusp is geometrically visible. This could all be due to light from the dark side in the twilight zone, but some of it may be due to light diffracted by the limb of the moon from the brighter parts of Venus that is geometrically hidden. Um, he has a graph shows this effect, and the graph A marks the first visibility of the twilight zone right here, and B marks the geometrically determined first detection of light from the northern cusp of Venus. That's way up here, but you can see it's starting to brighten before that.
The twilight zone, by the way, is well documented from measurements of the cusp extensions of Venus with suppression.
Right.
The cusps extend beyond 180 degrees.
Yeah, I've actually seen some pictures where you actually see the light all the way around.
We know how wide the twilight zone is, but it's said to be about 3 degrees wide.
Mm-hmm.
And interestingly, if we measure the twilight zone as you've detected, it's about 5 degrees wide. So actually, you detected the twilight zone earlier than observers have detected it historically.
Mm-hmm.
So I attribute that to your observation being made at night.
Right.
Whereas the other observations were all daytime observations with Venus fairly close to the sun and the sky.
I see.
So, this is something I've read about, quite a bit as an active ALCO observer of Venus,
Mm-hmm.
That's how I got this interest in it.
Oh, I see. Okay. Yeah, interesting. So anyway, it says C marks the first saturated pixel and D marks the last frame at which there was no saturation. So that was interesting. Yep, right. Okay. Next slide. Anyway, so your conclusions, the regression lines intersect at frame 373, which is thus the point of the first detectability of the light on the dark side. This frame has a timestamp at 1914-24, which is 8 seconds after the geometric first sliver of dark side reappearance. In summary, light from the dark side of Venus is definitely detected 19 seconds before the first detection of light from the twilight zone and 20 seconds before the geometrically determined reappearance. It's in remarkable agreement with Scotty's analysis. Roger speculates about the origin of Cytherean twilight or refracted light rather than light from the dark side. The detection of the dark side of Venus in the video can be presumed to be in the 110 nanometer window that is known to reveal the surface of Venus. The CCD chip can be expected to have a quantum efficiency of about 2% at this wavelength. So I think this should certainly be written up for publication. However, there's no significant new science in it. It may be of interest to professional astronomers, but will be intensely interesting to ALCO members who study Venus. So I think that's the last slide. There. Oh no. I go on. There's definitely more because I talk about the future. Anyway, Scotty and Roger claim the dark side, this is what we said, the dark side of Venus was detected in the video, but Tony George disagrees. But if Scotty's analysis is used, the dark side of Venus was comparable to a 10th magnitude star, or a third of the brightness of the Earthshine. And my inability to see the dark side visually and the similar 2001 quadrillion visual observations with an even larger telescope show that the dark side of Venus at best is very hard to see, even when the sunlit part is not visible. So it seems impossible to see the dark side directly visually with the overwhelming glare of the sunlit part of Venus. Unless there might be times when the dark side is much brighter visually, but I wouldn't know some temporal thing that might do that. Certainly attempts might be made with better equipment at future lunar occultations of Venus, so I will conclude with some the next chances. But any ashen light of Venus is quite faint according to the 2001 and 2015 observations. So although new observations might better quantify whatever ashen light is there, some is likely to exist at least from thermal emission. I think the conclusion that it can't be detected by direct visual observations will remain unchanged. Let's go to the next slides then. This shows the next opportunity after October last year. There was one in December last year. The white light is at nighttime, or the white line is the southern limit, and then here's the southern limit in daylight is the red line here, and then the occultation was just visible in the north. This occultation occurred under rather favorable conditions 2 months after the October event, but it was only visible at night in part of Alaska, but including Fairbanks and Anchorage there. As I remember, weather reports said it was clear, or only light clouds, but as far as I know, it was not observed. Some in the lower 48 states saw the daytime occultation, but of course they couldn't do anything with this experiment. So unfortunately, there was a pretty good opportunity. People could have got on an Alaskan Airlines flight and maybe use one of the observatories, the telescopes that already exist up there, or get the astronomers up there, but no one bit. Then the next chance after that is 2019. It's over Kwajalein again, so they have another chance 3 years from now. Maybe they have better sensitive detectors then. Not shown here are events that are too close to the sun, or where it's only 1% sunlit moon or so, and you're always in low altitude, extremely low altitude, and twilight. So I've excluded those. And I've excluded some of the waxing phase events where the sensor might be blinded by the sunlit side before the disappearance. I mean, Venus will disappear, and then theoretically you could have about 30 seconds where you can see the Earth shine, but you have this bright object before, and so you have to be careful. You could do a trick where you just turn on after it disappears, but you lose some of the information there. And then there are a few events in only inhospitable polar areas, some events that are just visible from the Arctic and Antarctic. In 2022, in southern Madagascar, Mauritius, and La Réunion, Kerguelen, there's another pretty good chance to see it. Next slide. And then New Zealand gets a chance in September 2028, so that's 6 years later. So these things don't happen that often. And so it's not, Venus is, you want a crescent Venus to be the ideal solution, like we had, but most of these are somewhat gibbous. So next slide. I just looked a little bit farther into the future, so there's a waxing phase chance that'll be visible in just at low altitude in California, Pacific Northwest, and then some other chances in the northeastern U.S. and in UK and Iberia get a chance in 2032. So we're getting pretty far out, but that's what we have. So those are both waning phase, those down there. Next slide. And the next Australian chance isn't until 2051, and it's not very good because it's waxing in very low altitude in the west coast of Australia. And then just in 2051, though, and a year later, New Zealand has another good chance. But yeah, it's, I won't be doing anything with those. Right. Richard.
Okay, it's a long time between these Venus occultations.
Mm-hmm.
I got a better idea.
Mm-hmm.
We create artificial occultations anytime we want using our existing equipment that we already have without putting a razor blade on the chip or a piece of cardboard or a piece of masking tape. I've done this before with double stars and Madrid.
Mm-hmm.
Not an unpublished study, which isn't published. I use the edge of the chip itself.
Uh-huh.
Uh-huh. And with the edge of the chip, you can orient the camera any way you want, and with slow motion controls, you can control how long the occultation is.
Uh-huh.
So you can never do this anytime you want.
Well, but yeah.
Doesn't cost anything. You do it in your backyard.
Yeah, but you're always, observing through our atmosphere, you're always going to get some glare from the sunlit side that you're going to see wherever you're looking, I think, in the area. So I, but if it's 10,
Right, is it 10th magnitude or 11th magnitude star?
yeah,
And I'm not sure whether a 10th or 11th magnitude star being occulted by Venus would be visible.
right,
So
no,
that
yeah,
gives you a clue that we still
yeah,
cannot see it.
yeah, we've, yeah, I know I've seen 7th magnitude, but, you know, things fainter than 9th I don't even consider.
So I don't think that would work.
Yeah, yeah. Okay, I think that's the end, yeah.
Well, let's just say thank you. We just want to thank everybody. We've had a number of great presentations, and thank you especially, David, for all the talking you've done today. We are behind. We'll see